Hello everyone, this is the fifth and final video for the lymphatic system. And in this video, we're going to cover some of the lymphatic organs and tissues that we haven't yet covered. So on the outline, these will include the spleen, which is considered to be a lymphatic organ because it is an encapsulated, discrete organ, and lymphatic tissues in which basically there are lymphatic nodules, packets of immune system cells embedded in other tissues. So these are the tonsils and the MALT, mucosa associated lymphatic tissues, which include Peyer's patches in the appendix. Just a word of note, I'm taking the tonsils as a separate feature in this outline, but if you look at many different books or resources, you'll find that tonsils are incorporated under the heading of MALT. So it differs in different sources. All right, so let's take a look at the spleen first. First of all, just some general features of the spleen. Spleen, in terms of lymphatic organs, is the largest by itself. Location of the spleen is the upper left abdominal quadrant, kind of up against the bottom of the diaphragm. It is posterior to the stomach and somewhat lateral to that as well. The spleen is kind of a comma-shaped organ, and it has an indented or concave side medially, convex, curved side laterally. On the concave side, there's a section called the hilum, and this is where blood vessels and nerves are going to enter into the spleen. The spleen is fed by a splenic artery, which is a branch off of the descending aorta. And that's going to enter into the spleen and branch extensively into arterioles. We'll talk a little bit more about the circulation in a minute. And blood is going to be drained from the spleen into a splenic vein, which merges into the inferior vena cava. Spleen is a capsulated structure, so it's covered by a dense, irregular connective tissue capsule. A couple of slides showing the gross anatomy of the spleen. So on the top here is a dissected abdomen in which the stomach has been removed. This is showing some of the lobes of the liver also have been removed. This would be the duodenum, so the stomach would be here. And here is the body of the spleen, like I said, kind of comma-shaped. So this would be the concave side facing medially and also inferiorly. And you can see the vessels attaching to the hilum here, splenic artery and splenic vein. And here is a magnified view of just the spleen, or mostly the spleen. And you can see the kind of curvature of it sitting up against the bottom of the diaphragm, and splenic artery shown here attaching into, you can't exactly see the hilum very well there. Okay. This is of the medial view of the spleen. We're looking at the concave surface. This is the hilum. Splenic artery, splenic vein are attaching and entering to the spleen at that location. As far as the internal anatomy of the spleen, so we're going to take a look at that in a couple of slides, and here are the things you should look out for. So the spleen has a fibrous capsule, and some of those fibers extend internally. This is much like the situation for a lymph node. They form partitions internally called the trabeculi, so they sector off the interior of the spleen. What you'll find in the spleen is areas where there's different kind of pigmentation. So those are called the white pulp and the red pulp. The red pulp obviously is redder in appearance. The white pulp is kind of palish, not exactly white, but a little bit paler in appearance. Now, there are different structures located, immune system cells located in these different areas, and they're carrying out different functions. In the white pulp, we have a lot of lymphocytes, T and B lymphocytes, especially B, and macrophages. And the white pulp is where a artery, which is a branch off of the splenic artery, is going to run through this structure, the white pulp. Surrounding the white pulp is red pulp. And the red pulp is redder because it has a lot of red blood cells, erythrocytes, platelets, macrophages, and also some B lymphocytes. Now, within the red pulp are these what are called splenic cords, and these are similar to the medullary cords and then in the lymph nodes. So these are containing reticular connective tissue and the fibers of those connective tissue, and this creates a space for blood to flow through it. So that's in the red pulp. Also in the red pulp, the central artery is going to branch into arterioles that are going to lead into the splenic sinusoid capillaries in the red pulp. If you remember, the sinusoids are extremely porous capillaries. And so they're going to let pretty much anything out of the bloodstream, including formed elements. And that's why there are red blood cells and platelets inside the tissue of the red pulp. Okay, so these are very permeable capillaries letting red blood cells and platelets out, and they can go back in as well through the walls of these capillaries. So these structures can leave the bloodstream and enter back in. Okay. So this slide is illustrating. Here is the splenic artery leading inside to the interior of the spleen, branching extensively, and these branches are going to radiate out to the surface. So this would be the convex surface on the up against the diaphragm, right? So the lateral kind of superior surface of the spleen. Okay, and here's a splenic vein draining blood from the spleen. Now this section here is focusing on what's happening out at the surface. Here's the capsule. Here there's some fibers radiating inward. Those are the trabeculi. You see those in intervals. And those are sectoring off areas of white pulp. Here's white pulp, surrounded by a large area of red pulp. Okay. The splenic artery is going to branch into these, what are called central arteries that run through the white pulp. They're going to branch into arterioles. You see these extensive set of arterioles. The arterioles are going to lead to the capillaries. Here are the sinusoid capillaries. All these kind of bluish blobs are meant to represent the sinusoid capillaries. So from these capillaries here, stuff is dribbling out. All kinds of material dribbling out of the bloodstream. Blood, formed elements, and including the red blood cells. So the main difference for the reason and the difference in pigmentation between the white pulp and the red pulp is because the sinusoid capillaries are located in the red pulp, and there are a lot of red blood cells that are percolating through this tissue. The white pulp does not have the sinusoids. No red blood cells are exiting there. Okay. This slide is an actual tissue section histology of the interior of the spleen, and this is a diagrammatic representation of what it looks like. So this would be the blood flow. This is a central artery running through the white pulp, and these are arterioles branching off of it, and they're going to lead into splenic sinusoid capillaries. And then the sinusoid capillaries are going to let a lot of stuff out, including red blood cells, and that's going to be forming the red pulp surrounding the white pulp. Okay, here you can see the trabeculi that are sectoring off one of these structures. White pulp surrounded by red pulp. You can't really see the blood vessels, but that's the actual kind of structure. Okay. The splenic cords illustrated here, you can't really see them so much in the histology section, but this is where there is reticular connective tissue with fibers creating a space for blood to flow and sort of percolate through this tissue. It's going to exit from the sinusoid capillaries, and it's going to filter through these splenic cords. And eventually, it's going to return into an into a venule, and it's going to start flowing out of the spleen. All right, so what's happening in the white pulp and the red pulp? What are the main functions? So in the white pulp, what you have are a lot of immune system cells, B and T lymphocytes, and the macrophages. What's happening in the white pulp is this is monitoring blood flowing through in these arterioles for foreign materials. This is where immune surveillance of blood is happening in the white pulp. Okay? The lymph nodes are carrying out immune surveillance of lymph. The spleen, especially the white pulp, is carrying out immune surveillance of blood. That's one of the chief functions of the spleen, immune surveillance of blood. Okay? What is the red pulp doing? Red pulp has lots of immune system cells as well, a lot of macrophages especially. Macrophages are phagocytic cells. So they're also involved in immune surveillance of blood. And they can be especially effective because the sinusoid capillaries are going to let a lot of blood out. So the macrophages are going to take up any kind of infectious organism, bacterium, virus, and take it in, break it down. They're also carrying out removal of defective red blood cells and platelets. So they're a general job, general kind of cleanup of the blood by taking out defective cells and taking out pathogens. Okay. The other functions being carried out in the red pulp are storage of breakdown products from the red blood cells. So, for example, hemoglobin gets broken down into amino acids. They can store amino acids temporarily. You can store lipids from breakdown of the plasma membrane. They can store iron temporarily from breakdown of the heme group. Okay. Also, third main function, the spleen can store platelets. Platelets that are let out from the sinusoids can be stored. Spleen is considered to be a reservoir for platelet storage. If you need them later on, they can be released. Okay, so I talked about three functions of the spleen. One is immune surveillance of blood. Two is breakdown of defective red blood cells and platelets and recycling of their products. Three is temporary storage site for platelets. Okay. Let's move on to the lymphatic tissues. And remember, definition for these are they have packets of immune system cells. You can call them nodules. And they're embedded in some other tissue. They're not encapsulated, so they're embedded somewhere. Tonsils are an example of this. Unencapsulated groups of lymphatic nodules, and they're embedded in the tissues around the pharynx and the oral cavity. Three main types given different names. Palatine are left and right side of the back of the oral cavity. Lingual tonsils are at the base of the tongue, and the pharyngeal tonsils are in the back superior wall of the nasopharynx. The pharyngeal tonsils are also known as the adenoids. All right, so this is showing the location. Pharyngeal here, kind of the roof of the nasopharynx. Palatine associated with a palate. And lingual tonsils, base of the tongue. Main function of the tonsils is they're trapping stuff coming in through the oral cavity, food and stuff like that. So that's an obviously susceptible point for stuff to enter into the body through the oral cavity and food, drink, or even through breathing. Okay. The structure of the tonsils makes them really good for trapping substances because they have these deep kind of valleys called the tonsillar crypts. And I'll show that on a slide in a second. So these crypts tend to tend to trap stuff coming in, and then they're in proximity to the lymphatic nodules containing immune system cells. So if they get trapped and recognized by immune cells as foreign, they will elicit an immune response to get rid of them. All right, so this is just repeating where the location is. And here is histological section through a tonsil, and it's showing it is partly encapsulated, but not completely encapsulated. Okay, so some of the structure is protruding out into the space. So it could be the space of the pharynx mostly, or somewhat also into the oral cavity. Okay, so it's going to be exposed to stuff coming through. And it has these deep grooves or crypts. So this stuff can be trapped in there. It's going to slow it down, and that's going to give up more opportunity for anything pathogenic, bacterium, to be exposed to immune system cells in the lymphatic nodule. And this is a magnification of this, and basically showing that if you look at the structure inside the tonsil, it's very similar to what you see in a lymph node. Is a germinal center, which is rich with B cells and sort of surrounded by a mantle zone, rich in T cells and macrophages. It's not covered by a capsule, but it's a bunch of these nodules kind of grouped together inside of a tonsil. Okay, and this is just a further magnification. I included this slide mostly because it's a really good illustration of the crypt. And look at all these crevasses for trapping stuff and bringing it close to the immune system cells in these lymphatic nodules. Okay, so that's what the tonsils are all about. Now, you can get tonsillitis, which is persistent chronic inflammation of the tonsils. And this appears, and some people are more susceptible to this, chronic infection and inflammation of the tonsils. And this is what they look like. These are pretty nasty. They're red, and they have this kind of pus-like exudate substance on the surface. So this is normal that they become swollen when they are, mounting an immune defense against some kind of infectious agent. But usually it's, not very long lasting, and it doesn't cause problems. Chronic inflammation of the tonsils, especially these, the palatines, can be very painful, and it can even impede the flow of food through the oral cavity. You can see here it's much reduced, the space, so it makes swallowing extremely painful. If this arises in a child, a chronic type of inflammation, tonsillitis, then one solution is to remove them. So that's a tonsillectomy. All right, last structure is actually not a structure, but a group of structures referred to as MALT, which is mucosa-associated lymphatic tissue. And this is lymphatic nodules that are not encapsulated. They're embedded in a mucosal membrane. And it could be any mucosal membrane, and that includes the digestive tract, respiratory tract, urinary tract, and the reproductive tract. Probably the most common and most well known are in the digestive tract. And those are called the Peyer's patches. So they are lymphatic nodules that are basically embedded in the lamina propria of the mucosal layer or in the submucosal layer. The mucosal membrane is a susceptible place in the body because it's lining passageways that open to the exterior. And so it's good that we have these kind of surveying what's coming into the body. And anything that's going to pass across the wall of, let's say, the small intestine is going to encounter these Peyer's patches within the wall. Probably the most common places are the Peyer's patches in the small and large intestines, and also in the appendix. So just one last slide here to talk about the MALT in the Peyer's patches in the appendix. Like I said before, sometimes the tonsils are classified as MALT as well. You can also find them in the walls of the bronchi, the large breathing tubes in the respiratory tract. And this is just showing for the small intestine. Here will be the lumen up here, the villi, and anything coming in across this epithelium isn't going to encounter these Peyer's patches before it's going to get into, the bloodstream or the interior of the body. All right, so I'm going to end this video here. That ends the material for the lymphatic chapter.